Okay, so we're back with our rational exponents and we're talking about our second form. And specifically what I mean by that is the numerator is not going to be 1 in this case for our rational exponents. And we do tend to separate them that way to think about just because the second form has a couple different meanings behind it. So it's a little easier to look at separately than the first one. Okay, so specifically what we're talking about here with our rational exponent is if we have a number or a letter or any expression to the m over n power. So m and n are going to be numbers. So you're going to see a fractional exponent there where our numerator is not 1. So we can interpret this rational exponent notation in two different radical notations. So the first one is we can interpret that, again, that denominator is still going to be the index on a radical. So we could say that's the nth root of a to the m. And we could put the numerator there as a power on that radicand. Or n is still the index of that root, and we have our base as a radicand, and then we can raise the whole radical expression to the m power. So it's just about the placement of that numerator, and there's a very specific reason for these alternate meanings of this notation, and it has to do with our product to power rule for exponents and the fact that multiplication is commutative. So, if you have more questions over that, you feel free to reach out to me specifically and I can get you some more information. Okay, so again, this is an equivalency statement. So a to the m over n has the same value as the nth root of a to the m power, or the nth root of a to the m power. And so because it's an equivalency statement, then we can also imply that we could read the nth root of a to the m, and the nth root of a to the m, so that both of those radical notation forms mean the same thing as a to the m over n power. So that's our rational exponent notation there. All right, so let's look at our first example. That first example is going to ask us to rewrite without rational exponents. So we're going to be given an expression in rational exponent form, and then you're going to be asked to, choose your favorite form. Now, I typically tend to favor the second radical notation translation of this rational exponent notation. Some people favor this form more, so it's really just a personal preference. So I'll show you both. Okay, so if we have 27 to the 2/3 power, so we want to rewrite that first without rational exponents. Okay, so I'm going to express it using my favorite form first. So cube root, so the denominator is still the index. The base is still the radicand. So that doesn't change from the work that we did in the previous two 6.2 videos. Just the only thing that we do have to add is that we're raising that entire radical expression to the second power. Okay, or you could have chosen to have translated that rational notation into the cube root of 27 squared. So you're going to take your base and put it underneath that radical and then raise it to the second power. Now, hopefully we can start to see that this can definitely be simplified. So we know that the cube root of 27, we've used this a couple times now, that the cube root of 27 has a value of 3, and then if we square that, as it says, so the cube root of 27 is 3, and then we square that, we get that this simplifies to a value of 9. Now, if you're having problems with that on your own, right, pull that calculator out to support. And now it is a cube root, but I am going to start it off with parentheses because you can see that my expression starts with a parenthesis. 3, I'm going to have to make sure I'm using my higher root radical symbol. 27, I need to arrow out so it closes down that radical symbol. And I'm going to put my parentheses, and then I'm going to square that expression. And that gives me a value of 9. All right, so let's come down to our second example here, and then we will be done with this portion of our 6.2. So we're going to rewrite with rational exponents here. So if I have the fourth root of 7xy raised to the fifth power, how would we translate that to our rational exponent notation? So again, I like to start with identifying what my base is going to be. So that radicand, the entire radicand, is the base of your exponential notation there, those rational exponents, and I am going to put it in parentheses. And then remember that index is the denominator of your rational exponent power, and then this power is going to be your numerator. And that's it. That's how we write with our rational exponent. So just make sure, again, that the entire radicand becomes the base of your rational exponent expression. So make sure that we're using those parentheses appropriately and that you're situating these numbers in your fraction. So index is always the denominator, and then this power gets placed in that numerator. All right.